Hello everyone. So this is going to be the last lesson of week 2 of distance learning. There's not going to be any Google form for this or any practice for this. However, after this lesson, you should then work on your assignment that's due on Monday, April the 20th by 9 a.m. So you still have to learn this lesson so that you have the knowledge you need to complete the assignment. We're going to be talking about what happens when you add a load in series to a circuit versus when you add a load in parallel to a circuit. So I've got my circuit construction kit here, and I've just got a basic circuit with one battery, one light bulb. Okay, that's it. One battery, one light bulb. I've got a couple of ammeters here just to show you what the current is. So that's how fast the charges are going through the circuit. And as you can see, they're going at the same speed in these two parts of the circuit at 0.9 amps. I've also got a voltmeter here that I've connected to the two ends of the light bulb. So this is measuring the voltage that's being consumed by that light bulb. So that light bulb is using 9 volts. And that's because the battery is providing 9 volts. Okay, so what is going to happen when I add a second light bulb to this circuit in series? Okay, we'll do series first and parallel after. So series means the same pathway. So I'm going to take the second light bulb, and I'm going to put the second light bulb right into this pathway. So I'm going to unhook this connection point here. And then I'm going to put the light bulb in and reconnect it. And adding that second light bulb had an effect. Okay, it definitely had an effect on this circuit, and it actually has 3 effects that I want to highlight here. The first thing it did was it made the first light bulb less bright. So I'm going to redo that actually, just so you can double check that. So this was the original light bulb. Look how bright it is. And it's using up 9 volts. So when I add the second light bulb, the light bulb's not so bright anymore. Okay, and that's because the 9 volts that it had before, well, it's not using 9 volts anymore. Now this light bulb's only using 4.5 volts because it has to share the voltage with the second light bulb that's there now. So these 2 light bulbs are each using 4.5 volts. So that's one thing that adding a load in series does. It takes some of the voltage away from the loads that were already in that pathway. The second thing it does is that it adds more resistance to this pathway. So with only one light bulb there was only 10 ohms of resistance. Well, now with 2 light bulbs in the pathway, there's actually 20 ohms of resistance in this pathway, which leads to our third effect. So what happens when you have more resistance? Well, then the charges get slowed down more. So the current, which I don't know if you noticed what it was before, it was at 0.9 amps before. Well, now the current's down to 0.45 amps. Okay, so those are the 3 things that happen when you add a load in a series. You take some of the volts away from the loads already there. You increase the total resistance, and that causes the current to slow down. Okay, so that's what happens when you add a load in series. And all of that is written out for you in the notes provided on Google Classroom. The slideshow is, as usual. So it's all on this one slide here. Adding a load in series. These are the 3 things that I said it did. And these are just 2 screenshots of the circuits there, with the 1 bulb to start, and you can see all the numbers that resulted with only one light bulb. And when we added the second light bulb in series, you can see how it affected all of those numbers. Now I'm going to focus for adding a load in parallel. So I'm back to one light bulb here. Okay, one light bulb is using up 9 volts, and the current being created is 0.9 amps. So I'm going to add a second light bulb, but this time I'm adding it in parallel. See what happens when you add it in parallel. So just as a review, parallel means we're going to create a whole nother pathway for it. So I'm actually going to leave the light bulb up here. I'm going to add some more wires to create a whole new pathway for the second light bulb. And there we go. Okay, I've added the second light bulb, this time in parallel. And how did it affect everything else? Well, the results might surprise you this time. They're not as intuitive, but I'll try to explain why. So first of all, how did adding this bulb affect the first bulb that was already there? You may notice that it didn't affect it at all. The voltmeter attached to it still shows 9 volts. It didn't change. And the current going through that pathway with the first light bulb is still 0.9 amps. Okay, so that's one big difference between adding a load in parallel versus adding a load in series. Adding a load in parallel does not affect the voltage of the original light bulb. And that's because it has its own pathway. So by having its own pathway, it doesn't really affect the first pathway here. Okay, but another effect that might be a bit surprising is the current down here. The current down here is 1.8 amps, so it actually got faster. And I can easily show you by disconnecting this here. I'm going to break this pathway. When I disconnect it, it will not flow up there anymore. So here, with just one light bulb working, the current was 0.9 amps. I'll reconnect this. Now with the second pathway working, the current is bigger. Okay. So adding a new pathway makes the charges move faster through the battery. And that might be counterintuitive. You might think adding, because the light bulbs have resistance, so adding resistance, you think it should make things slow down. But look, we didn't just add resistance. We actually added, we did add resistance, but we added a whole new pathway to travel as well. So think about just traffic in a city. What happens if a city only had one road and everybody had to go on one road to get from place to place? Well, that road would be very, very slow. You'd have a traffic jam the whole time. Okay, things would be going very slow. But then if you build more roads so that people have different options of different routes they can take, that will improve the traffic flow and let the cars go faster. Okay, so that's kind of how you can think about what's happening here is I didn't just add another light bulb, I've added a whole new road, a whole new pathway for electrons to choose from. So that allows them to drive a bit faster in some parts of the circuit. Okay, so adding a light bulb in parallel does not affect the previous light bulb. It makes the current go faster through the battery, So that must mean it affected the resistance somehow. So the only way for electrons to go faster is if there's less resistance. So by adding a whole new pathway in parallel, we actually decreased the total resistance in the circuit. And that's the important thing to know about adding a load in parallel. So this is all summarized in the last slide here, and there's a mistake. This should say parallel. So I'm going to fix that in the slideshow for your notes. But the last slide should be adding a load in parallel. 3 things to note. 1, it does not affect the voltage of the original loads. It decreases the total resistance of the overall circuit, which causes an increase in the current at the power source. Okay, and these are just the 2 screenshots of the circuits, one with just the 1 light bulb and the other with the second one added in parallel. You can see all the numbers in these screenshots. Then you can check that these 3 things are actually true. So that's the last lesson. What you need to do now is go to the last section of this week on Google Classroom, and that's where you'll find your assignment for this week. This is going to be marked. It will count towards your marks. The due date is on Monday, April the 20th at 9 a.m. So anything after 9 a.m. submitted will be subject to late penalties. And you're going to need to know things from both weeks of distance learning to do this assignment. Okay, so you're going to need to know the names of the different components of the circuit. You're going to need to know how to draw circuit diagrams and read circuit diagrams. You're going to need to know about series versus parallel and how to build circuits in series and parallel using the virtual circuit construction kit. And then you're going to have to work with numbers as well, do a little bit of math, okay, using Ohm's law. Don't forget that you can either use the formula for Ohm's law if you're like good with working with equations, but if you're a little more worried about working with the equations, one hack, I guess, is to use a circuit construction kit and just play around with the values until you get the values that you're asked for. All right, we're going to put all that together in one assignment so that I can assess how well you learned the stuff from the first 2 weeks of distance learning. Okay, so I look forward to those submissions. And then I guess I'll see you next week.